Hello and good evening, CSI 135 Section 400 students for the fall 2013 semester at Anne Arundel Community College. The video here will go ahead and be the lab number 3 solution set. So without further ado, let's take a look and see what kind of mail we have here. And I'm logged in with my student account, CSI135-400. So as you can see, we've got Lab 3 for week number 4, which was given out on the 18th. And here are the instructions for the lab. And it says it's going to require you to pull together a lot of the concepts that we've covered so far in order to complete this lab. Alright, so we're going to go ahead and complete these steps one at a time, and I'll do them down here in my second shell window. Alright, so the first one, question number 1 for the lab, says in your home directory, create a directory with the name of Spring 2013. And again, this directory needs to be all uppercase because Linux and Unix are case sensitive. So you could simply issue the make dir Spring 2013 and hit enter. As you can see, it already exists. So let me do an rm-rf on Spring 2013. And so let's clear the screen here. So we'll do a make dir Spring 2013. And now when I type ls, you can see that I've got a directory here, Spring 2013. So again, the command was just simply make dir Spring 2013. And I'll get an error message now because again it exists. Alright, so change the permissions on the directory you created in step number 1, which is Spring 2013, to 755. So if I do an ls-l, if you look and see, the permissions are actually already set to 755. So it was to have you check. If you didn't check and you ran chmod space 755 on Spring 2013, that would have also changed the permissions had they not been 755. Alright, so in the Spring 2013 directory, we are asked to create a number of subdirectories. So as you can see, if I use the pwd utility, it'll print my current working directory, which is Spring 2013. So now I'll do make dir labs, make dir homework, make dir tests, make dir notes, and quizzes was misspelled there, so it's Q-U-I-Z-Z-E-S, make dir quizzes, and make dir foo, right? And again, it wants you to change the permissions. So we'll do chmod 755 on labs, which is what it was already set to. It's the default. We'll do a chmod 700 on homework, chmod 754 on tests. We'll do a chmod 755 again, which was the default, on notes, chmod 700 on quizzes, and finally chmod 751 on foo. Okay. So number 5 asks you to change the permissions on your home directory to 755. And the reason for this is so that I can get into your home directory, or the script that I run can get into your home directory to see if you've actually created everything you're supposed to have created for this lab. So to do that, I can't do it, well, I could do it from here, and I guess let's take a look at that. So if I did chmod 755, I could use the tilde, which would be the absolute path name representation of my home directory, because again the tilde represents the absolute path name. So that's one way to do it. I could have cd'd space ... and remember the ... represents the parent directory to the directory that you're in. So if I typed pwd, you can see that we're currently in Spring 2013. It's also displayed here inside my prompt. So when I type cd space ... I'm actually changing directories to one directory above the directory I'm currently in, so the parent directory. So the parent directory of Spring 2013 is B25, and that happens to be my home directory. And again, to get there, I could simply type cd by itself. That would put me there. If I was still in Spring 2013, I could type cd space ... And again, you don't need the ... You can use cd by itself, and irrespective of where you're at in the file system, cd by itself will return you to your home directory. So cd ... would also place me back in my home directory. Okay, I could have also, if I was still in the Spring directory, in order to run the chmod command, I could have done chmod 755 and then provided the absolute path name to my home directory. Now, when you compare that command with that command, it's clear that this is probably the preferred method to make that change. Or, if you're actually in your home directory, you could simply type in chmod space 755 and the dot. And remember from last week, the period by itself represents the current working directory. So by running that command, I'm saying change the permissions to 755, or change the mode to 755 for the current working directory. And as you can see here, the current working directory is displayed as part of my prompt. It's the tilde, which represents my home directory. So that would also have the same effect. In order to confirm this, if I type ls space dash L, whoops, I apologize, ls space dash LA, because we need to see the hidden files, remembering that the hidden files are any files that begin with a period. So here's the period by itself, and this represents, again, the current working directory, which, as we can see, here's my home directory. So the permissions on the current working directory are 755. Another way to check this is to simply move up a directory into CSI135-B and type ls-LA. However, this is clearly not the preferred method, because now I'm left to scroll back through all the directories that have been listed out for me. Oops, excuse me. And I need to find B25, and so here I am. And I could also see it here. But again, clearly not the preferred method. The preferred method is to be in my home directory, cd by itself and enter, and then ls-LA dot. And that'll list out all of the files in my home directory, including the permissions on the current working directory, which is 755. Okay. Now, the next one says create a tar file of your home directory and all of its subdirectories, and do this in your home directory. So let me clear the screen. Now, this would what I was looking for here was to have you take a look at the man page, because we had mentioned tar, but I didn't give any examples of tar. So if you take a look at the man page on tar, you can see that there's a -C for create, and we'll go down here, and -F, right, stands for the file. But if you look at the man page for tar, it actually shows you some examples right out of the gate. So you can see you can create a bzipped tar archive of the directory called bar. You could extract from a tar file with the -X, right? So we want to create. Okay, we want to create. And it doesn't need to be bzipped. It just simply says create a tar file. So I could do tar space C, and I'm going to use the VF, right? And typically you do -CVF, right? And now this is the name of the file, and I'll just call it homedir.tar. Whoops. Homedir.tar. Now, what do I want to tar up? Again, I'm in the current working directory, or I'm sorry, I'm in my home directory, which is my current working directory. So I can simply do a period. I'm going to hit enter. You're going to see one error message that's going to appear, and typically it's of this form, and it's basically tar telling you that it's not dumping the tar file itself, because this is the file we're creating. So this file is not included in the tar file. And remember, the tar file, which stands for tape archive, is simply used to create an archive file of all the files, including the hidden files. As you can see here, it's adding the hidden files in, right? Your .bashrc, .viminfo, .bash profile. Those files have been added in even though they're hidden files. So if I type ls, you can see I have a tar file here that's called homedir.tar. Now I'm going to remove homedir.tar, and we're going to take a look at the man page for tar again, and we'll take a look at one of the other examples. So this example here, create a bzipped tar archive of the directory bar called foo.tar.bz. Now, if you don't put the .tar, then it's difficult to tell whether or not it's a tar file. So what I could do right? I could type tar cvf, whoops, dash cvf, and I could just call it tar file and do the current working directory. So you can see I have this file down here called tar file, and there's no extension. So the tar utility does not append .tar to the end of the file name automatically. It's something that you need to do when you're naming the file that you're going to create, right? So I'm going to rm tar file, and we'll get rid of that. And actually, let me run that again. So if I had this file called tar file, if I ran file against it, then you can see it's a POSIX tar archive. But it's a lot easier, and let me run this again here, we'll pull it back up. It's a lot easier if you simply name the file tarfile.tar, or whatever name you're going to give it, .tar. Because then when I do an ls, it's clear to see that this is a tar file, right? So let's do an ls-l, whoops, long listing, and you can see we have a tar file here. And the size of the tar file is substantially larger than any of the other files that are listed here in the home directory. Because again, the tar file is a compilation of all of the files that are in the directory in which I've created the tar file, and all of their subdirectories. Okay, so let's remove tar file one last time. We'll take a look at the man page for tar, and we want to save as much space as we can. So this is also an option, right? You can create a bzipped archive, and the command is right there, cv, and I'll do jf, and we're going to call this homedir.tar.bz2, and I'm going to do the current working directory. So I'm going to hit enter, I'll type ls, and there you go. And let's see, the other file was, when I had just tarred it up by itself, was 61440. So 61,440 bytes. And let's go ahead and take a look now and see the size of the file. So where is homedir.tar? So as you can see, by a factor of about 6, yeah, so let's say about 5 or 6 times smaller when I bzipped it and tarred it than when I simply just left it tarred. So this is always a good idea, especially if you're dealing with any kind of file system quotas where you're only allowed to have a certain amount of space in your home directory. All right, so that definitely answered number 6. All right, number 7 says move the .tar file that I created in step number 5 into the labs directory. And so this is where you're going to have to use absolute or relative path names. So let's clear the screen here. I'll type ls. So there's my tar file, homedir.tar.bz. And I know that the labs directory is located in spring 2013. So as you can see here, there's a couple of ways I can do this. And again, let me get the current working directory, the absolute path name printed up. So I could simply type move homedir.tar.bz2 to spring 2013/labs. So if I hit enter, that command will work. What I could have also done, and again, this is using relative path names, right? So this is the relative path name since it does not begin with the /. And remember, the relative path name, think of it in terms of this is the path to the labs directory relative to where I'm currently at in the file system. If you wanted to use the absolute path name, and so let me move this back, spring labs, homedir, and I'm going to move it right back here to the current working directory. And so that's what this command has just done. I basically moved it back out of the spring 2013 labs directory and put it right here in my home directory. What I could have also done is I could have said move, and I could have said homedir.tar.bz, and again, this is referring to it as a relative path name. And I could have used the absolute path name as such. Now, when you compare these two commands, this command here, which uses the relative path name for the file, and then the relative path name for the destination directory of the file, and you compare it to this command here, right, where you've got much more room for error in having to type all of this out or to copy and paste and maybe making a mistake. It's clear that if you can get away with the relative path name, that would probably be the easiest way to do it. But I wanted to make sure I showed you both methods. All right, so if I type ls, you'll see that homedir.tar.bz2 is no longer here, but if I list out Spring 2013 labs, the file has been moved there. All right, so that was step number 7. And let me bring us up to step number 8. What option could you have used with the tar command that would have tarred and gzipped the file all in one single tar command? So we showed the bzip command, so let's take a look at the man page for tar. So here we go. As you can see, common options, right? And so again, that was the purpose of this question, was to get you to take a look at the man page, to get you to come down just a little ways here to see some of the examples that you could use. And again, it shows you how to create the file. And then if you would have taken a look here, you would have seen the -z would gzip the file as well. And so again, I'm in my home directory. I'm going to type in tar space -cvzf, and we're going to call this homedir.tar.gz, and I'm going to go ahead and say the current working directory. So I hit enter, I type ls, and you can see I've got homedir.tar.gz. So now if I run file against homedir.tar.gz, you can see that it'll tell you immediately it's a gzip compressed file, right? So let's see. We had talked a little bit about the functionality of bzip2 as compared to gzip and which algorithm is most efficient when compressing files. So if I type ls space -lai, and I'm going to throw the inode numbers in there just in case. So here we go. As you can see, when I gzip the directory after tarring it, the size is 20,000 bytes, right? If you remember the previous example with bzip2, it shrunk it down to 9,700, I believe. And actually, let's take a look. ls-l on Spring 2013 labs. So clearly, 20,300 bytes, the size is almost twice as big when using gzip as opposed to using bz2. So here, bzip clearly has an advantage and has definitely saved about twice as much space as using gzip. Okay, so -z would have been the option that you could have used. What does the period represent? We talked about that. It represents the current working directory. What does the ... represent? We talked about that. The ... represents the parent directory, or the directory immediately above your current working location. Okay, you have just run the following command from your home directory and received the following error. Make dir temp stuff junk kids. Make dir cannot create directory. No such file or directory. And the conditions are that given that the temp directory exists, but that the directory stuff does not, provide the single command that could be used, and we're going to say that you're in your home directory when you run it, that would successfully create the desired directories. And so what this wanted you to use was an example that we had seen during lecture, which is the -p option. And the -p will create any of the interceding or intermediate directories if they don't exist. So let me first do an ls on /temp/stuff/junk/kjds. And clearly there's the message right there. No such file or directory does not exist. So I'm going to type in make dir, and actually we can simulate this. So there's the same command, and you can see cannot create no such file or directory. So if I type in make dir -p, stuff exists, so looks like someone else may have created it. So I'll tell you what, we're going to change it just a little bit. I'll type in temp, and we'll call this CSI135-400 question. And what question number is this? 11. All right, we'll do that instead. And we definitely know that directory doesn't exist either. Okay, but it does now. So the -p option would create the intermediate directory. So if I type the man on make dir and hit enter, and there's that -p, parents. No error if existing, make parent directories as needed. So remember, these directories here, stuff, junk, and kjds, did not exist. By using the -p, it creates the parent directories as it goes down. Okay, so it would have been make dir -p and then those directory names for your answer. Number 12, what is the default numeric access permission setting on new files you create? And I'm looking for the numeric representation of the mode. So if I were to type in touch junk and then type ls-l, you can see that the owner has read-write, the group has read, and everyone else has read. So it would be 644. So the answer for the default mode is 644. What's the default numeric access permission setting on new directories that you create? We'd already seen that. I'll go ahead and do it again. Let's type in make dir, and I'll type in fall 2013, and then we'll run ls-l. And you can see fall 2013. The owner is read, write, execute. That's 7. The group is read, write permission is off, and execute permission is on. That's 5. And then again, same for other. So 755 is your default permission setting on new directories that you create. Okay, let me scoot up a little bit here for number 14. In the following directory, create, it says there are 2 files. What are the inode numbers of the files, and what does that tell you about the files? So let's cd into /temp/CSI135-400, and we're going to go into files, and we'll type in ls-lai, right? And remember, the I will show me the inode numbers. So I can see the 2 files are here. Default mode on them is 644, and the inode numbers are identical. And so what that tells me is that these 2 files, junk and stuff, are hard linked. The other giveaway is that you can see the link count for each is 2. So these files are clearly linked to each other. Okay, why would you receive the following error? Print working directory, and it shows that you're in your home directory, and then I'm going to create a link called junk to /temp/new junk. So let me go into my home directory. Whoops, let me clear the screen, pwd. So let's run this command, junk /temp/new junk. See if we get that same error. We do, invalid cross-device link. So without the -s, when you go to use the ln command to create a link, it creates a hard link by default. And again, that is without the -s option. S as in Sam. So the reason that I can't create a hard link in this instance is that from my home directory, which is on one partition, the /u partition, I cannot create a hard link into another partition. It cannot be a cross-device link. And remember, we had spoken about that each partition has its own set of inode numbers. And so there's no way to guarantee that the inode number from the file we are going to create the hard link from to the file that we're going to create the hard link to, that if they span file system partitions, that those inode numbers would be available on both file system partitions. And so the answer is that you're trying to create a hard link across file system partitions, and you cannot do that. All right, number 16, and I'll just come up here for this one. So it asks, what are the file permissions represented numerically? So for A, it is 427, so 427. For B, it is 747. For C, it would be 113. For D, it would be 001. For E, it would be 024. For F, it would be 661. For G, it would be 557. For H, it would be 707. And for I, it would be 441. And again, remembering that the R has a value of 4, the W a value of 2, and the X a value of 1. And that's for each of the 3 permission settings, which are owner, are the first 3, the group, that the file belongs to is the second set of permissions, and the final set of permissions is everyone else. So if you're not the owner of the file, and you're not a member of the group which is assigned to the file, your permissions would be the last three, which is everyone else. Okay. And so now we're going to be asked to create a series of directories in the temp directory. See, number 17 asks us to create some directories in the temp directory. Now, if I'm in my home directory, I can create these directories from my home directory, but I would have to use the absolute path name. So I could type make dir /temp/ and it wants you to create CSI135-B and then your login ID. And in my case, it's B25_09, and the date the lab was handed out, which is the 18th, 2013. And I'll hit enter. So if I type ls/temp, you can see that a number of the directories have been created by the students who have been doing the labs, and here's the directory that I just created. So now it asks you, it says in the directory that you created in step 17 above, create the following 6 subdirectories. And again, I can do this all from my home directory /temp/CSI135-B25_09, and there it is. And it wants you to create RA_v_ENS. And again, you can just simply use the up arrow to recall, and then we'll do 49ers. And the 49ers today is Sunday, September 22nd. The 49ers did not do too good today, or too well today. So the 49ers didn't look that exciting. So lab number 3. And then we're going to do make dir WEDNESDAY. And then we're going to create another directory called Math is Hard and Homework. All right, so the directories have been created. That was number 18. Now we'll come down to number 19. What will the contents of the file not junk be after you run the following series of commands in the order presented? So typically what I like to do for questions like this is to actually create the file and run the commands just like they're shown. So if I cat the etc hosts file out, etc hosts file, and I'm going to append it to my stuff, or actually let me make sure we don't have anything called my stuff first. So there we go. So we'll cat etc hosts and put it into my stuff. I'm going to copy my stuff over to junk. I'm going to move junk, so I'm basically renaming the file junk to not junk. All right, and then I'm going to run the date command, and I'm going to redirect the output of the date command into not junk. So the question asks you, what are the contents going to be? It's simply going to be the date, current system date and time, Sunday, September 22nd at 9 p.m. Okay, so that was number 19. So the contents will be the current system date and time. Number 20, what will the contents of the file mv be after you run the following series of commands? So again, let me clear the screen. So I'm going to run the hostname command, and I'm going to redirect the output to a file called cp. I'm going to move cp, and I'm going to change, so I'm basically moving, and this is the utility, the file cp, so don't confuse that with the copy command, right? Because it's simply the file that we created here in step 1. And I'm going to move it to a file named mv, which is not the move utility. So if I type ls-l on mv, you can see I have a file there called mv. So now I'm going to copy mv to mv.1. I'm going to run the uptime command, and I'm going to append it. Remember, the greater than represents append to mv.1, and then I'm going to move mv.1 to mv. So what will the contents of the file mv be after you're all done? It should be the hostname command along with the current system uptime. And as you can see, it's vader.aacc.edu. So the output from this first command here is listed here, and then we've got the uptime of the system and also the load average. Right? So that would be the contents of the file. All right, I'm going to come up to number 21. In the directory that you created in 18A above, create a file with the name, months, that contains a list of all the months that occur in the year, and it wants them to be spelled out. So let's take a look at 18A. So that's ravens. All right, so I'm going to cd into temp slash CSI135-400 underscore 0908 slash ravens. And that's the absolute path name to where I'm currently located, right? Okay, so let's create a file called months. So I'm going to use the VI editor, which is actually, again, a link to Vim. And we'll do January and February and March, April, May, June, July, August, September, October, November, December. All right. So we'll save that file. Let me clear the screen. I'm going to cat out that file, and there you go. So what does it want us to do with that file? Each month is on a line by itself, so we're good there. So number 22 says, if you were able to run the following command on the file that you just created, and it says here in number 5, and this is a typo, it's referring to number 21, so the months file that we just created. So if I ran tail-5 months, what would I see? Tail -5 months, and as you can see, I see the last 5 lines of the file, right? 1, 2, 3, 4, and 5. So tail-5 shows me the last 5. By default, how many lines will tail show? Well, let's find out. Tail months, it's going to show me 10. So by default, tail will show you the last 10 lines of a file. And as you can see, January and February are not listed above. Okay, so that was number 23. Let me scoot up here. Number 24 in the directory that you created in 18B above. Let me scroll back up here. 18B is 49ers. All right, so it's asking me to create a file with the months of the year in alphabetical order and do this using the utility sort. The name of the file must be alphabetical underscore months. So let me cd back here, and I'm going to cd into the 49ers directory. So now it says using the sort command. Well, we've already created a file named months, and it's located in the ravens directory. So there's a couple ways I could do this, and I'm going to go ahead and show you this one here. So I can cat out the file months, right? I can create a pipeline and run it through sort, and let's see what we get. Sure enough, we have a file, or I'm sorry, sure enough, we have output from the file months that has been arranged in alphabetical order. So at this point, all that's left to do is to redirect the output of that command to the file alphabetical months. And I hit enter. So now if I cat alphabetical months, there they are, just like the output. All right, number 25, in the directory you created in 18B above, which is also the 49ers directory, create a file with the months of the year in reverse alphabetical order, and do this using the sort utility. The name of the file must be rev alphabetical months. So we already know that, right now we have that file alphabetical months, so there's no reason that we can't sort it in reverse order. Now, if we're not sure of what the reverse order sorting option is for sort, we can type in man space sort. And let's take a look at the man page, and there you have it. -R or -- reverse. So we're going to do -R. It's a little easier. So again, that file that I have here is alphabetical months. I could type in sort alphabetical months. Whoops, correction. Let me go back. Control U. Do Control U there. So I could type in sort space -R alphabetical months, and let's see if we get it in reverse order. We certainly do. So now all that's left to do is to redirect the output from that command into a file called rev alphabetical underscore months. And now we're done. And as you can see, I now have alphabetical months and reverse alphabetical months. So that was number 25. Number 26. Starting with the first Super Bowl played in January 15th, 1967, create a file in the directory you created in 18F. Let's go back up to 18F, which is homework, and put in a chronological list of the first 10 teams to lose the Super Bowl. The file must have the name losers. For example, the list would begin like this: Kansas City Chiefs, Oakland Raiders, and so on. Okay, so we're going to go ahead and we're going to create that. Okay, so as you can see here, I've pulled up a Google search that's taken me to ESPN, and it's given me a list of all the teams that have lost the Super Bowl. So let me slide this over here a little bit. All right, there we go, a little better. So in the homework file, so cd space / homework, it asks me to create a file, and we're on number 26, chronological list of the first 10 teams to lose the Super Bowl. So we'll create the file called losers, and in this file I'm going to put down Kansas City. I'll put the name of the team, Chiefs. We'll put down Oakland Raiders. Unfortunately, my favorite team. It's not doing too well lately. Baltimore, and of course back then they were the Colts. Minnesota Vikings. Dallas Cowboys. Miami Dolphins. Washington Redskins. Minnesota Vikings again. And if you want to see the line numbers so you know where you're at, you can use set number or just simply set NU. And so that shows me a list of the lines, or a number next to each of the lines. So we had the Vikings, and I believe we were Redskins, Vikings, and it looks like Minnesota lost again. Minnesota Vikings. And then what did we have? We had the Dallas Cowboys one more time. Oops. And the Dallas Cowboys one more time, and we'll save that file. All right, so that's the losers of the Super Bowl. It says create a copy of the file that I just created, so CP space losers, and we're going to call this super losers underscore copy underscore 09182013. All right, so now we have two files here, and we just created a copy, and you'll notice that the sizes are identical, 170 bytes. Okay, so number 28 asks, in the same directory that you were in for number 26, create a new file with the name revlosers, and in that file you should have a reverse alphabetical listing of the super losers file. So an easy way to do this would be sort-r super losers, and we're going to send the output to the screen right now, and as you can see, this is definitely reverse sorted order. So all that's left to do now is to redirect the output into the file called rev_losers. And as you can see, we now have all three of those files in this directory. Okay. Now let me scoot up here a little bit. They're coming down to the last couple of questions. So number 29, whoops. Come back up to number 29. So in the directory you created an 18E above, and we're going to have to scroll back. 18E is math is hard. And we'll pull this down a little bit. So I'm going to move out of the homework directory and go into the math is hard directory. It says create a file called primes, and the 10 consecutive prime numbers starting with 103, each on a line by themselves. So we already know we've got 103. So 103, 107, and then 109, and I'm going to have to come over here. And again, remember that Google is your friend. List of prime numbers. All right, so the first 1,000 prime numbers. So let's see, we were at 107, 109, so we'll slide this guy over just a little, see if we can squeeze it in there. Resize these windows. Actually, we've got this window here. So after 109, we've got 113. And again, if I want to set the numbers, I could type set NU. And we get a list there. And actually, I want to undo that. All right, so we have 103. We've got 103, 107, 109. Apologize, let me get this back here. And we've got 109. I've got 113. And I've got 127, 131, 137, 139, and make sure I get this right here, 139, 149, and 151. Okay, so there are the first 10 primes starting at 103. So we'll save that. And I can go ahead and move this window out of the way here. Let's resize this guy up. All right. 10 consecutive prime numbers starting with 103. There they are. So in the directory that we created in 18E, which is the directory we're in here, math is hard, it says create a reverse numerical sort. So if I type sort on primes, you can see it's still in the order in which we've placed it. If I didn't know the option, let me backspace up here, if I didn't know the option for sort, I could type in man space sort. And as you can see here, it can do a numeric sort, compare according to the string numerical value, right? And so let's see what that looks like. If I type in sort space dash n on primes, it puts it in that order, but I want it in reverse order. Remember, it's asking for the primes to be put in reverse numerical order. So would dash r work? And it certainly does. As you can see, 151 is now first, followed by 149, 139, all the way down to 103. So all that's left at this point is to redirect the output of that command into rev underscore primes. And there you go. And we now have two files. If I cat rev underscore primes, there they are in reverse order. All right, that was number 30. Number 31, in your home directory, create a file named .mailrc, and it's a customization file for the mail utility. Using the mail man page, add into the .mailrc file the option that will automatically ask you for the BCC line, and also add an option to unset or no longer prompt you for the CC line. So let me cd to my home directory. If I type in, and I believe, let me remove this file to make sure it's gone. So I'm pretty sure I created it. So there I have no .mailrc file. So when I send a mail message right now, and we'll just call this test to teacher to TPB, and I say this is a test, you can see that when I hit a period on the line by itself, indicating to the mail utility that I'm ready to send this message to the intended recipient, I'm automatically prompted for a CC line, so I could CC myself. That way I receive a copy of the same email that I've just sent the teacher. And that's number 2, and there it is. Okay, so I'm going to go ahead and quit from mail right now. I'm going to clear my screen. So 31 is asking you to create the .mailrc file, and you would do that with the VI utility and the name of the file. But we need to know how to set the options for BCC and how to unset the options for the CC prompt. So if I type man space mail, I'm going to get the man page for mail. And if you scroll down, and you need to scroll down a little ways here, right? And there are some of the different tilde options you can use. So here are your mail options, and these are controlled via a set or unset command, right? And as you can see, ask CC that's what's causing me to be prompted with the CC. I want to set the ask BCC and unset ask CC. So I would simply quit. I'll vi.mailrc, and I'm going to set ask BCC, and I'm going to unset ask CC. I'm going to hit escape and shift ZZ to save that file. Let's clear the screen. So if I cat.mailrc, those are the two lines that I have. So let's test. If I try to send a mail to the teacher now, whoops, TPB, this is my second test, and now I'm going to go ahead and do a period on a line by itself, telling the mail utility I'm ready to send, and hit enter. You can see that now I'm asked for a BCC line, not the CC line. So those settings in the .mailrc file have been successful. If I type in mail, you can see that here the new message is clearly the one I just sent. So we'll type in number 2. That's my second test. I'll type in Q to quit. And so again, this is what your .mailrc file should look like. All right, finally, number 32, list out all of the mail options that are set on the system for you automatically. It says, hint, use the man page to find the location of the system-wide file for mail options. It's in the etc directory, and this is the key. So let's go back to those options on the mail man page. We'll page our way down till we get to the options section, which was right after the tilde escapes. And you can see right here that /etc/mailrc is typically where things are set. If you come down here to the bottom of the options that you can set and unset, right, and then they end right here, okay? So typically the etc/mail.rc file is where the universal settings are set for the mail command. So let's cd to /etc and let's cat mail.rc and see what's set. Sure enough, you can see this is where it was asking for the CC line. And since we didn't have it overridden in our home directory with our own configuration file for the for the mail utility, it was simply asking us, giving us the options that are set system-wide. So the answer to the question would be /etc/mail.rc. So if you don't have a .mailrc file in your home directory and you haven't customized mail, the system will set the following settings for you to give you a little more functionality. All right, that's lab number 3. I hope you found the lab informative, challenging, and educational. I will see all of you on Wednesday evening. Drive safely and enjoy the rest of your weekend.